All right, here we are at our 8.11 SOHCAHTOA nodes. So we're going to be discovering some of our trig functions and how they're used. Now, generally speaking, the start of it's not too bad. And then a lot of the calculator tends to take over. Okay, so that's just kind of a quick preview for what you guys are going to see today. Now, we're going to start off with some definitions just to kind of guide us into how SOHCAHTOA works. This is an acronym that you're going to hear for many years. And again, at first, when my guys usually first see this, they're kind of like they're trying to make sense of it, and it's a little hard at first. So just kind of keep that in mind as we kind of just define what SOHCAHTOA actually is. But generally, when we see it in action with some numbers, students start to see, oh, okay, this is where this number goes, and this is where this value goes. Okay, and SOHCAHTOA is really designed to find values when you can't really use Pythagorean theorem and you do have an angle measure, or even sometimes you're actually finding an angle measure. So this is where SOHCAHTOA is especially handy. Now, this acronym is broken up into three different like little trig functions. And so the first one is the sine function. Okay. And that stands for opposite over hypotenuse. So again, for the sine function, it is opposite over hypotenuse. Now we're going to get to the CA. CA stands for cosine function. So this is our cosine function. And that would be our adjacent over the hypotenuse. Okay. And then finally, we have our tangent function. Switch up colors. This is our tangent function, which is our opposite over our adjacent. And so these opposite and adjacents, they essentially just stand for the positions of what your values are in those lengths for our right triangle. I'll give you guys a moment to go ahead and jot those down. But again, SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and TOA is our tangent function, opposite over adjacent. All right, so now let's go ahead and see this in action. So here is our right triangle. And for this one, we have the sine of C. And we're trying to figure out, well, what is the sine of C? So as we look, we're trying to figure out what is the sine of this angle measure right here. And recall a moment ago, sine of C is opposite over hypotenuse. And so as we look at this angle measure, we're trying to figure out, well, what's the side length opposite of that? That would be 21. So on the top, we have the 21. And on the bottom, our 29. I'm sorry, our hypotenuse is the measure directly opposite of the 90 degrees. So this is your hypotenuse. So that would be 29. So the sine of C is 21 over 29. And that's actually pretty much it. Like that's how we find our value. Now for now, we're just kind of just doing the setup just to get more familiar with our trig functions. Okay. We're going to go ahead and just do the odds for now, and then you guys will have practice for the evens. All right, now looking at the cosine of C. Well, cosine of C is adjacent over the hypotenuse, according to our definition. So here is our angle measure C, and it's not always going to be here, just so you know. It can be up here at times. So just be mindful of where your angle is. And our adjacent is not the one opposite, but it's right next to your angle measure. So in this case, it's that value 36 on top. And then our hypotenuse is the one opposite of the 90 degrees, so 39. Now we can actually simplify this up. And so our cosine of C comes out to be 12 over 13, because we can divide the top and bottom both by 3. And that's how we get our 12 over 13. Again, really just identifying what's where here. And finally, for number 5, we're trying to figure out the tangent of A. Well, the tangent of A is opposite over adjacent. And so then for our tangent of A, here's our angle measure A. It is the one opposite of that. So that would be 12 on top over the adjacent, the guy right next to our angle measure, 35. It cannot be simplified any further, so that's actually it. Go ahead, feel free to pause the video if you have any questions on the sine, cosine, tangent placements of the values. So yeah. All right, next up, we are looking at finding the value of the trig ratio to the nearest 10,000. Now, for the first one, essentially, guys, what you have to do here is in your calculator, you'll see a sine button. Go ahead, click the sine. And again, this is if you have the big calculator. I highly suggest the big calculator, the TI-84 plus CE. If you have the little one, this should work as well. But so you have the sine, and then what will happen is it'll automatically open up a parenthesis, and then you have to hit 62. Now, when you do that, you should end up with the value of 0.8829, and then 4 is this last digit, but we care about the 10,000ths. So there's 10th, 100th, 1,000th, 10,000. We would look at the 4, well, it's under 5, so then it's going to stay the way it is. Now, you may not have gotten this value. You may not have gotten this one. It is the correct value, but what you need to do, especially if you have the big calculator, what I need for you guys to do is click on Math. My apologies, I meant to say Mode. You're going to click on Mode. So I'll give you a second. Clear out of there. Go into Mode, and then you're going to scroll down with the arrow. So down arrow. Until you get to radian/degree. And what we need to do, I think it's like the third option. What we need to do is scroll over arrow, and we need our values to be in degree mode. So make sure that it's highlighted on degree mode. Your calculator may already have it on degree mode, but it's got to be in degree mode. And then hit enter. And now, if you back out of there, it will be in the degree mode. So if your answer didn't match what we just got a moment ago, that's why. It's because your calculator is in radian mode. If you have any questions on how to change this into degree mode, feel free to pause and ask me. All right, now we're going to go ahead and try and find the cosine of 60 degrees. Well, essentially, guys, you literally just plug it in your calculator. So you hit the cosine key, it opens that parentheses, 60, close the parentheses. Trust me, it's a good habit. And then hit enter. And when you do that, you end up with 0.5. Next up, again, really, guys, we're just getting exposure to how to enter this in the calculator. So go ahead, hit the tangent key, 79, close the parentheses. And then when we do that, we end up with about 5.1446 as your value. Go ahead, feel free to pause the video if you have any questions on 7 through 11. All right, for our next one, this is really where you're going to kind of start seeing these trig functions come in handy, okay? So right here on number 13, we have a triangle. And unfortunately, we only have one side of this triangle, right? We know the side length opposite of that is our hypotenuse. So this guy right here is our hypotenuse. And so because we're missing two sides, you can't even use Pythagorean theorem here to find a side. And then that's really where these trig functions come in handy, the SOHCAHTOA. Now, what we have to ask ourselves is which trig function are we going to use? So there's kind of a process that I would jot these down. So the first one is, what is our trig function? Which one are we going to use here? Well, that depends on the information that we're given. So we see here's our angle measure. And based upon this angle measure, where it's at, we have the side length opposite of that we're trying to find. So if we're looking for that value, that opposite would include sine or tangent. One of those two. Cosine's out because cosine just has adjacent. And then we also have our hypotenuse. So our two here that we have are the opposite and the hypotenuse. And so that really steers you then into the sine function. You have to use the sine function here. So we have the sine of 59 degrees, because that is our angle measure, equals our opposite. So in this case, it is the x over the hypotenuse is 17. So step 2 is we're creating the equation. And there we did that. So here's our equation. Again, we had to use the sine function. There's our angle measure that we had to use it with. 59 degrees is equal to the opposite of that 59, which is x, over the hypotenuse, which is 17. Now step 3 is going to kick in. We have to solve for x. And so really this is where a lot of your algebra skills kind of just kick in. And so what we're going to go ahead and do is to solve for x, we're going to multiply both sides by 17. And when we do that, the 17s cancel here. So we have 17 sine of 59 equals x. And then lastly, we pretty much just calculator this. Okay. And so when we plug this into the calculator, we end up with a value x coming out to be about 14.6. And so on your paper, in your notes, I would definitely have these written down. So you're first going to figure out what's your trig function. Then with that, you're going to create your equation. You're going to solve for x, and that's going to look a little bit different depending on the question. And then lastly, you just calculator it. Go ahead, feel free to pause the video if you have any questions on this one. All right, next up, we have number 15. So what I would love for you guys to do is to pause the video and try this one out. It's very similar to our last one, but go ahead, give it a shot. Pause the video, give it a shot. All right, so in this one, we have our angle measure right here that's given. We know the hypotenuse is given. And with this angle measure, we know our adjacent side is also given. Remember, the hypotenuse is always opposite of 90 degrees, so that's got to be the hypotenuse right there. And we have our adjacent. So you have adjacent and hypotenuse included. Well, there's your cosine function. So step one, boom, we've got our cosine function. We know we're using the cosine guy. Step two is like, hey, let's create our equation now. So again, this is adjacent over the hypotenuse. Step two is saying, okay, create the equation. So we have the cosine of 27 degrees, because that's our angle measure given, equals the adjacent, which is x. We don't know it, but it's involved, and that's what we're trying to find, over 20, the hypotenuse. Okay, fantastic. Now, step three is like, great, now let's solve for it. So we're going to multiply both sides by 20, get x all alone. There he is. Those 20s cancel, so x is all alone. Equals 20 cosine of 27. And now, lastly, calculator this. So we're going to dump this into a calculator and then see what we get. So it looks like x comes to be about 17.8. And so this is 17.8 in terms of a distance right there, that length right there. Now looking at number 4. Go ahead, feel free to pause the video, give it a shot. It is a little bit different, but it's still doable. I mean, you're still gonna be using your algebraic skills, but go ahead, give it a shot and see if we come up with the same values in the end. All right, again, for our first one, number 1, we have to identify what is our trig function here. Well, we have our angle measure right here. And we have the side opposite of that. So we know opposite is involved. And we know adjacent is involved with our angle measure. We don't know the hypotenuse on this one. So because we know the opposite side and the adjacent side, this forces our tangent function. So we have to use the tangent function here. So step 2 is going to kick in now, and we're actually going to create this equation then. We have the tangent of our angle measure, which is 40 degrees, equals opposite, which is, in this case, 20, right? Opposite is 20. Adjacent is our x. So we actually have x on the bottom this time. And now we're going to go ahead and try and solve for x. We want to get x all alone on one side. Well, right now it's on the bottom, and so we kind of have to like bring it up. It's very similar to how we have been doing it. So we're just going to multiply both sides by x. And here they cancel out with one another. So we have x tangent of 40 equals 20. And this is fantastic, but we still need x all alone, right? And so this x is stuck and glued to the tangent of 40, so we're going to unstick it by dividing both sides by the tan of 40. Now, when we do that, these cancel out on the left side. And so x is equal to 20 divided by tangent of 40. And then at this point, again, this is really step 3 kicking in. We're going to go ahead and throw this into a calculator. Now, again, this is one set on top, so use those parentheses. Trust me, they do help. So open up a parenthesis, 20, close parenthesis, divide, open parenthesis, tan, 40, close parenthesis. And when we do that, our x value comes out to be about 23.8. Okay. Now, again, really it is about, so you would see the squiggles, but since we're dealing with trig functions, it almost most of the time implies it's going to be an about. So I'm okay personally with equals because you're kind of really still walking through all the motions and still solving appropriately. All right. It is an about though. Go ahead, feel free to pause the video if you have any questions at all. All right, next up, we are shifting gears, and this time we have to find an angle measure. So we're not finding a side length now, we're actually finding an angle measure. And yes, it says question mark. I'm going to use just X just to make it easier for us, just so that we actually have a variable. So we're going to use X there instead. Now, our trig functions are still exactly the same. SOHCAHTOA still holds, okay? And so looking at this, well, here's our unknown. We'll zoom in a little bit. Here's our unknown. And we have the side length opposite of that. So we know opposite is involved. And then we also have the hypotenuse, which is opposite of the 90 degrees. So that would be your hypotenuse right there. And that, as a result, kicks in our sine function. So we know that we have to use the sine function. So again, that is step one. And I had a fantastic question the other day. They're like, hey, Mr. B, but isn't it really like, here's your unknown, and isn't that adjacent with it? And I'm like, it is, you're not wrong, but it's also your hypotenuse. And so really the adjacent would be this side, and your hypotenuse is this side. And so that's what kind of distinguishes between the two. So fantastic question. Shout out to that student. Now, step two kicks in. We have to create our equation. And for our equation, we have the sine of X. Again, we don't know what X is. We're trying to figure that out. Equals our 39, because that's what's opposite of it, over the hypotenuse 44. Now, how do we get X alone? Because step three is kicking in. We got to solve for X, right? Well, there's a lot of fantastic ideas. A lot of students do not write this down. Please don't write this down. But a lot of students think, actually, I'm gonna pause. Go ahead, think, how could you solve for this? I don't want to spoil it just yet. All right. Hopefully that's been kind of enough time to kind of think about it, what you could do. A lot of students, they're like, again, don't jot this down, but they're like, hey, I'm going to divide this sine on both sides and be like, yay, cancel. Well, let's keep in mind, the sine is actually a trig function. So you're dividing by a sine of something, and you're not having a something there. So it's not acting like a coefficient like we're very, very used to in math. So if you were thinking that, I promise you, you're not alone. I've seen that many a times. Instead, it would truly, how do I put this? Very few students figure this out on their own. So if you don't know, don't feel bad. But again, I'll give you guys another moment to try it out. All right. Now, the reason why I do pause like that is because I have seen some students actually be like, hey, this is what you have to do. And it's because they kind of look at stuff on their calculator and they kind of like, maybe this is involved somehow. And so I have seen it. Like, it does impress me that these students may actually get to the true result. And so it is definitely possible. It's just very rare. Not many people can get this on their own. So if you didn't, that's totally normal, actually. What we have to do, if we're trying to figure out an angle measure, that's what this is. We're trying to figure out what X is, which is an angle. We have to use the sine inverse of both sides. And so, on your calculator, there's that key, right? It says like you have the sine function. Well, the one right above that is the sine inverse. And so that's used to actually find an angle measure. Now, what happens when we do the sine inverse on both sides, like we are currently, and you see in the blue, is your sine inverse comes together with your sine function, and they cancel out with one another on the left side, leaving you your X. And then that's equal to the sine inverse of 39 divided by 44. And now how you enter that in is you have to hit the second key at the top left of your calculator. And then you're going to hit sine. That's going to pull up your sine inverse. And then you just type in your fraction, 39/44. And then we get that x comes to about like 62 degrees in this one. And that is the angle measure right there. Comes out to be 62. All right, let's go ahead and see another one in action, another example, maybe a different trig function. So here is your x value. And we have the hypotenuse given. And we know that we also have our adjacent. So the cosine function, again, this is step one, the cosine deals with adjacent and the hypotenuse. Now step two is going to kick in. We got to create our equation. Well, we have the cosine of some angle. Let's give ourselves some more space. We have the cosine of some angle x that we don't know equals the 24. We have 24 over 36. Now, again, we want to just get x all alone. So we're going to do the cosine inverse of both sides. So when we do that, the cosine comes together with the cosine inverse, leaving you just your x. And then we type that into a calculator and we end up with, so again, this is step three. Step four is like, hey, what's your x? In the calculator, comes out to be about 48 degrees. And that's really it. I mean, that's pretty much all it really boils down to. Now, again, I had a fantastic question the other day. Students were like, hey, Mr. B, can I simplify that 24 over 36? And I'm like, yeah, absolutely. You absolutely can. Now let's see the why really quickly. So, try that again. Imagine here's your original triangle, right? 24, 36, your angle measure, x, right? Now, if we were to simplify this up, imagine what you would be doing is they had pretty much just a smaller triangle with 2 over 3, something like that. And in the end, though, you're still going to have that same angle measure. So you could absolutely simplify this. It's not really going to make any difference, though. Okay. But you absolutely could. All right. Now, looking at 23, go ahead, pause the video, give 23 a shot. I usually have them try it out, and then we'll come back together and see how we did. All right, coming back together now, we have our unknown x, and we notice that we have the length opposite of that, so opposite is involved, and our length directly adjacent. Be careful, we don't have the hypotenuse. Remember, hypotenuse is always opposite of the 90 degrees, right? So we have the opposite and the adjacent side this time, which creates your tangent function. Got to use tangent. So there is step one. Step two, we're going to create our equation. So we have the tangent of some unknown angle that we don't know equals our opposite, which is 10, over 33, which is our adjacent. Now, step three is going to kick in. We got to solve. So we're going to take the tangent inverse of both sides. These guys come together, leaving you just your x that you want. And now we have to just pretty much plug that into a calculator. And so for our step four, we see that x comes to about 17 degrees. Okay. So again, this is purely, you use the inverse functions when you're trying to find an angle measure. Want to be very clear there when you're looking for an angle. All right. Now, looking at number 25, we have to find the angle measure to the nearest degree. Okay. Well, we've got the sine of x equals 0.7547. And you're like, you might be thinking, well, we have this decimal, but I know if I try and find an angle measure, I just have to do the inverse. Well, remember a moment ago how we had those ratios like 10/33, and we had something like 24/36, right? Those trig ratios, those are a decimal, keep in mind. Like that's a fraction, which is a decimal. And really, for these are even easier, even though they come out to be a weird decimal. Literally, they're already giving you the ratio. So you don't even have to create the triangle. Like you can pretty much skip 1, 2, and even step 3. All of those are really just handed to you already. Essentially, all you need to do is just do the sine inverse of both sides. Boom, boom, x is all alone equals, and then dump that into the calculator. Like that's all. And so when we do the sine inverse of this decimal, we end up with about 49 degrees. And boom, there's your angle. Okay. Go ahead and feel free to pause the video if you have any questions, but I'd also love you guys to try number 27 and 29. Generally, when my students see the first one, they're like, okay, I know exactly what I have to do. So I'm not going to walk through the process. I'm just going to give you guys the values that we got as a class. So for Y, it would have come out to be 55 degrees. And then for B, for the tangent one, we got 32 degrees. But again, if you have any questions, pause the video, feel free to ask. All right. Moving on, now we're getting to the meat and potatoes. Here we have word problems, okay? And these word problems, I assure you, are pretty much staples when it comes to this trig stuff, okay? You're going to see them again and again and again. We're going to kind of highlight some of the certain ones, but I might leave, we'll save 31 for the last one, not because it's like not a good question. It's just I'd rather kind of lean you into the direction that you're more going to encounter. So as we look at 32, we have a horizontal distance of 80 meters. From the horizontal distance of 80 meters, the angle of elevation to the top of the flagpole is 18 degrees. Okay, yeah, so this is known as the flagpole question. All right, so again, it's a flagpole. It says at first the horizontal distance is 80 meters. So right there is a horizontal distance of 80 meters. And it says that it has an angle of elevation of the flagpole. So imagine here's a flagpole. Oh, that was rough. Let's try that again. So we have a flagpole. And that angle of elevation to the top of the flagpole is 18 degrees. Okay. And what we have to do is find out how big the flagpole is. So how high up is that flagpole? Well, we notice that it creates this 90 degrees, so we can then use SOHCAHTOA. And again, for the flagpole question, staple question, you have to pretty much use your trig functions then, okay? Now, I'm going to start off by saying this too. For these word problems, I am telling you, you have to draw a picture, okay? Always. You have to draw a picture. When? Always. Wait a minute, when again? always draw a picture, okay? I guarantee you it's really going to help you out. It's going to tell you what is where, and then you'll be able to go from there, okay? And generally, those students get those questions right. So always draw a picture. I know in the past I've seen like pre-calc teachers and other teachers, like, because they use this in pre-calc too, where they actually give a point for creating the drawing. Like you get points there, but it can also save you in placing your values where they really belong. Now, we have to calculate the height of the flagpole. Well, here's our angle measure. Looks like we're dealing with opposite. So opposite and adjacent. So 80. Oops. 80. Or adjacent. So opposite and adjacent, boom, we're dealing with our tangent function. Okay. And so to set it up, we have the tangent of 18 degrees was that angle measure. Boom, there's our angle. Equals opposite, we don't know. We're going to call him X for the moment. So X over 80, the adjacent. And now we pretty much, there's your equation. We're going to go into step 3, which is solving. So to do that, we're going to multiply both sides by 80. These cancel. X is all alone equals 80 tan of 18. Throw that into the calculator. And so we see that X comes out to be 26 meters. So the height of that flagpole is 26 meters. Some teachers like the little sentence too, so the height of the flagpole is 26 meters. I'm just going to do it for this first one, but some teachers really want that. Okay. Now, the second question, or number 33. All right, for our next one, 39. We have a 9-meter ladder rests against the side of a wall. The bottom of the ladder is 5 meters from the base of the wall. Okay, so our ladder is 9 meters. Okay, so we have a ladder. Again, we start off by drawing a picture. And we have this ladder that is 9 meters. And it's resting against the wall. So here's our wall. And it says the bottom of the ladder is 1.5 meters from the base of the wall. So the bottom of the ladder is 1.5 meters from the wall. So this is 1.5. I know it's not exactly drawn to scale, but you kind of get the idea. This is 1.5 meters from the wall. Now, in this question, it says determine the measure of the angle. So we're trying to figure out the angle between the ladder and the ground to the nearest degree. So we're not trying to figure out how high up the wall is. We're trying to figure out what is this angle that the ladder is from the ground. Okay, so now kicking in our SOHCAHTOA. Well, we do have our adjacent side and our hypotenuse side. And so keeping in mind, adjacent and hypotenuse is going to yield our cosine function. So we know that we're going to have to use our cosine function here. Setting up our equation, we have the cosine of x equals 1.5 divided by 9. And now we want to go ahead and solve. Since we're trying to find an angle measure, we have to use the cosine inverse of both sides. Cosine inverse comes together with cosine. And so we end up with x equals the cosine inverse of the 1.5 over 9. And then lastly, we just dump that into a calculator. And we see that X comes out to be 80 degrees. So our angle with this ladder is 80 degrees. So really, guys, as you guys are seeing, it's pretty much just here's a word question and then put the numbers really where they belong. Okay. Next up, we're going to try number 34. This is known as kind of the tree with a shadow, or generally a shadow question. So it's a shadow question. You have the angle of elevation of the sun is 68 degrees when a tree casts a shadow. So imagine we have a tree. So we have a tree. And let's do a nice pine tree sticking up. And it says that the angle of elevation from the tree casts a shadow from the sun. So here's your sun. And it casts a shadow at an angle. And let's fix that. Let's fix this side real quick. And this angle that they give us is 68 degrees. So there's our sun. It's casting this shadow. So here's your shadow from the tree. And that angle is 68 degrees from like the edge of the shadow to the sun. And then it tells us that the shadow is 14.3 meters long. Okay, so we know our shadow is 14.3 meters long. And then the question is, how tall is the tree? So we don't know how tall this tree is. So we're just going to have X there. All right, so then we're ready to go for our trig function. So step one is, which trig function are we dealing with? Well, we have the opposite of that. So X, we have the opposite, and we also have the adjacent. So again, the 90 degrees, this would be your hypotenuse right here. But we do have the adjacent. And so the trig function that goes with opposite and adjacent is tangent. So we know we're using tan. Step two, we're going to go ahead and kick in our equation. So the tangent of 68 degrees equals opposite. We don't know what it is. It's X over adjacent is 14.3. And now we go ahead and solve for X. We are going to multiply both sides by 14.3. Boom, boom. Here they cancel. X is all alone equals 14.3 tan 68. We throw that into the calculator. And we see that we end up with about 35.4 meters. Okay. The hardest part with these is actually part of it is the drawing, but really knowing what number goes where. And that's the purpose of the drawing. And then creating the equation. But generally, once students have the drawing down with the numbers where they belong, generally they're okay even with the equation. Okay. All right. So guys, we're not going to do the 35 and 36 because essentially, guys, I do want you to get some reps with it. I am going to say though, for 36, it does ask two questions. And again, 35 deals with a wheelchair ramp. Very common question. So it's known as the wheelchair ramp question. 36 is the kite question. So, these things are very common, in other words. And then again, though, with 36, you have to find out how high the kite is and how far away the kite is horizontally. So this actually has two different questions. Okay, so just keep that in mind for 36. The main staples are truly the ones that we just did, the three questions. Like you have the flagpole question, you have the ladder question, and you have the shadow question. Those are like more than likely you're going to see on a test, not just with me, but like just in general in high school too. There's one last part that we do have to discuss super quickly. Looking at 31, it's just kind of the terminology that they use. An airplane is flying, and again, there's an airplane question. It's kind of a staple. So you have an airplane is flying at an altitude of 6,000 meters over the ocean directly toward the coastline. So you have an altitude of an airplane. Is flying above the ocean. We have it right above an ocean. And its altitude is 6,000. So altitude would represent height. So really, guys, I'm just going to help you out with the drawing part first and kind of like the start of it. So the height is 6,000 here. Now, at a certain time, the angle of depression to the coastline from the airplane is 14 degrees. So when they say angle of depression, okay, angle of depression, imagine you have this plane and you kind of just draw like a horizontal line. Let's draw that a little bit better. There we go. So it's going, straight, and then it has an angle of depression because its goal is to kind of start like landing near the coastline. When they say angle of depression, they're really talking about this value right here is 14 degrees. Okay, so it's starting to go down by 14 degrees. Well, if you recall, and again, if we haven't gotten to this in the year, I know for this year we have, but if you haven't, that's okay. For angle of depression, recall parallel lines sliced with a transversal, right? Imagine this is a parallel line with this guy. Well, and then this red line is acting as our transversal. Okay. Now, if that is 14 degrees, where else is it 14 degrees? It would be right here, 14 degrees. And the reason for that is those are alternate interior angles. Again, if you haven't gotten to there yet, though, that's totally okay. Another way that you could view it is, since you know that the altitude is 6,000, you could put 6,000 right here as well. And then you have your kind of similar triangles just upside down is all. So like see where you have your angle measure, your 6,000, and then like you'd have your adjacent here and your hypotenuse here. So you could solve it that way as well. Okay. But generally we kind of like triangles upright. So that's why I did that. All right. So now that you guys have enough, here's 14 degrees. Now that you guys have enough, you guys should be able to find and solve for, it looks like 31, they want you to find how far does the airplane have to fly before it directly reaches the coastline. Yeah. And then also, what is the angle of inclination? So there you're finding an angle. And then 36, you're finding the height of the kite and the horizontal height or the horizontal distance. So go ahead, please try out 31, 35, and 36 as well. And again, guys, those are our 8.11 set of notes dealing with trig functions. So again, SOHCAHTOA, we kind of just quick recap. We started off by essentially just labeling, hey, this is what is SOHCAHTOA, and this is where the values belong. Just kind of getting more familiar with what goes where. Then we learned how to program things into a calculator. And then this is where really the math kicked in with the 4 steps in finding a segment length. And then finally moved into how to find an angle using SOHCAHTOA. Using the calculator again, where they already pretty much set it up for us. And then finally some application questions. But again, that is our 8.11 set of notes.